Hello everyone and welcome to IC Compiler, IC Validator in Design, Incremental Training, Part 2. Agenda. As mentioned in my previous presentation, IC Validator in Design Update Training has been divided into two parts. Part 1 consists of the following features, that are: add mode support for track-based metal fill insertion. Second, dense fill in the automatic ECO track fill flow. In this section, I will be covering Part 2 features, that are: first, improved distributed processing. Second, metal density reporting. Let's move on to the first feature, that is improved distributed processing. Problem description. The InDesign commands which run IC Validator get launched from an IC Compiler 2 shell, which is usually resident on a single machine. Hence, to reduce runtime, user can take advantage of multi-threading and distributed functionality that is built into IC Validator. This may include, but is not limited to, starting IC Validator on a multiple host and opportunistically adding more hosts to the running IC Validator job. Overview and benefits. The largest benefits that has seen by the user through this feature will be the turnaround time. Through flexible configuration, native IC Validator distributing processing features are enabled in ICCII environment. This enhancement also improves the native support of LSF and adds the add host functionality, which will enable opportunistic addition of additional hosts. User interface. To support this feature, new option has been added to the pre-existing command set host options. The two options are target and add_hosts. First option -target has a value of ICV. When this switch is used, the configuration specified for the set host options will only be applied to the InDesign flows. And when this switch is turned off, the settings are considered global and are applied to all flows. The next option is add_host. This switch is Boolean and the default value is off. With this switch, now the user can set two configurations, one for the main job and one for the opportunistic host adding. With these two new options, that is target and add_hosts, the user can create two distinct configurations for InDesign flows, one for the main job and one for the opportunistic flows. Please note, if there is no configuration that uses the option -target ICV as value, the InDesign flows will use the global configuration. This enhancement also clarifies the usage of -num_processes and -max_cores. This enhancement also clarifies the usage of option -num_processes or -max_cores. So when a flow uses a named host, the num_processes and max_cores can be used interchangeable, and this will identify how many CPUs to use on the host. If both are specified, their product will be used. When a flow uses acquired hosts using a system such as LSF, the switches are interpreted slightly different. num_processes refers to the number of hosts, while max_cores refers to the number of cores per host. Please note, num_processes refers to the number of hosts and max_cores refers to the number of cores per host. Use models. As shown in the slide, there are 4 different use models, and we will go into each one in detail. So these 4 different usage models are differentiated by 2 different criteria. Use models number 1 and 3 have IC Validator running on the same host as IC Compiler 2. This is shown in the first row of the slide. Use model number 2 and number 4 have IC Validator running on different hosts. This is shown in the second row. Use model number 1 and 2 do not use the opportunistic host adding. This is shown in the first column. While use model number 3 and 4 use the opportunistic host adding, and this is shown in the second column. Use model number 1, that is IC Validator runs on the local host. For use model number 1, the user can specify either max_cores or num_processes. Please note, if both are specified, that is max_cores and num_processes, then their product will be used. In these examples, since no host or host acquisition method is specified, IC Validator will run on the local host with the number of CPUs specified. Let's move on to use model 2, that is IC Validator run on a remote host. So for use model number 2, by passing in a host as an argument to the command set_host_options, the user actually instructs the IC Validator to run on that host. Once again, please note that max cores and num_processes are interchangeable, and if both are specified, their product will be used. For example, in the first row, the IC Validator will run on host H1 with 1 CPU. Now consider an example where a user specifies more than one host, as shown in the row 1. Use model 2. IC Validator runs on a remote host, that is LSF. The switch submit_protocol can be used to identify a machine acquisition system. The most common is LSF, and it is supported through this feature. Now, the option -num_processes will identify the number of hosts to use, while the max_cores option identifies the number of cores per host. These different configurations will all have IC Validator running on an acquired host, with the number of CPUs used will be specified by the user. Use model IC Validator runs on a remote host ICV-LSF. When the option submit_command is used, the number of CPUs that get passed to the command is specified using the -dp syntax. This ICV-LSF utility will accept the -dp syntax and convert it into appropriate queuing commands acquiring host in a similar way as the native LSF method. Use Model 3 IC Validator runs on the local host and add more hosts. For use Model 3, the add_hosts functionality works in addition to the functionality that are previously discussed. It takes advantage of LSF features that allow hosts to be assigned as they become available. The machine configurations that are specified with add_host are both optional resources and maximum resources. The resources that may be given to IC Validator at the beginning, middle, or end of the run are not given at all. For use Model 4, all of this queuing functionality can be used together to set up a very robust distributed environment. Let's move on to the last feature of this training, that is metal density reporting. Overview. As we all know, at advanced nodes, metal fill is mandatory to ensure manufacturability and high yield. Metal shapes that fill empty tracks are required to meet minimum metal fill density rules, while the metal shape also should meet the metal fill gradient rules. This feature addresses functionality to develop an easier way to report density. To support this new feature, new command signoff_report_metal_density has been added for calculating and reporting metal density. Metal density reporting flow. As shown in the slide, if you have a routed DB with metal fill and you execute the command signoff_report_metal_density, all the density reports will be generated. Usage. This new command signoff_report_metal_density works only for metal and wire layers. It uses the layer names defined in a technology file. If this information is not specified, the command uses the grid sizes defined in technology file for the layers. It generates density reports for all routing layers within the minimum and maximum routing layers. Usage. This slide shows how the density rules are defined in the tech file. User interface. As mentioned earlier, the new command to support this feature is signoff_report_metal_density with the following options of output, select_layers, coordinates, and starting_points. In addition to this command, we have also provided 5 app options for better user control. Please take a moment to go through all of them. With this, we come to an end to our training today. Thank you for listening.